trigonometric solved equation. So most of our solutions will be in approximate forms, okay, because in this course we're not going to develop the full set of skills to be able to solve equations accurately. So we're going to find graphically the number solution for the equation sine x is equal to x over 2. Okay, so it's not asking you to do an accurate graph, however we can keep it reasonably accurate, it will make things a bit easier. So what we need to do, y equals sine of x and y equals x over 2. So set both sides of the equation equal y. What you're going to do is graph those two functions, and then the intersection points will be your solution. Right. So we've got sine of x and x over 2. So let's do our sine curve. Sometimes the questions will also give you a domain, right? So you're going to consider that when we're answering question. I probably should actually do, probably need to do more of that graph, because when we consider x over 2, we're going to have part of your solution over here as well. So let's start again. Alright, what is pi on 2? Approximately. Hey? No, not sine of pi on 2. What is pi on 2 in decimal form?
45.
Pardon? No, not in degree form, in decimal. So if we put pi over 2 on your calculator and push equals
1.75.
No. Whack! Yep, crack the whip. Right, so in decimal form pi is 3.14. Okay? Just so we can get it accurate, can we just put pi on 2 in the calculator and tell me what you get 2 decimal places? Somebody? Anybody? Help me out here. Pi over 2, half pi. Just checking the rounding also.
1.57.
Alright. Well, it's going to be that or the other one, wasn't it? Just checking. Alright, 3 pi on 2 by times pi over 2 by times by 3. Just so we have reasonably accurate. 4.71 and 2 pi. Can't just say 6.28. Check that rounding. 6.2 what?
3.141.
Hey, because pi on 2 is representing the distance of 1.57 from the axis. Okay, so you have x equals 1, to, you know, show force like we normally do, but because of the our degree measure, our angle measure in radian, when radian is each specifying a distance, okay, we need to consider that as we're graphing. So if y equals x over 2, okay, so the gradient is 1 over 2, we're going to rise 1 and then a rise of 1, then a run of 2. Okay, so rise of 1 and then 2 is going to be, I would say, somewhere around there. Okay, join that up with the origin. And it has to be reasonably accurate because we need to solve. Alright, so we need to have a reasonably accurate so that we have the correct solution, or a good approximation to the solution, more so. Alright, so what is the obvious solution to our graph? Where the two curves intersect. So one at the origin, okay, that's the obvious one, where they intersect. Alright, we know that x equals 0. Alright, so from that we need the approximate solution. Okay, so in other words, we need to find this value for x here. Alright, that gives it approximately the same y value. Alright, and then from the graph, I know it's going to be somewhere between 1.57 and 3.14. So this is where you'll need to go to calculator. I would go maybe 2. So try x equals 2. So let's call this y1 and y2. So 2 over 2 is 1. So we know that y2 is 1. What is sine of 2 in radian mode? Somebody? Anybody? Help me out here. Okay, so your calculator is set in radian mode, and I need you to calculate sine of 2 for me.
0.909.
What was it?
0.909.
909. So we're close to the solution being equal for y1, y2. Okay, so you need to fiddle around with it a bit. So x 2.1. Okay, so what is sine of 2.1? Alright, and what is 2.1 divided by 2? 2.1 divided by 2. Pardon? 2.1 divided by 2. 1.05. Okay, which one's the better approximation to the solution? So in other words, which one of the y values closer together? The first two. Okay, these two are much closer together than those two in comparison. So x equals 2 would be an approximate solution. Okay, so I'm going to go one more the other way. So x 1.9. So can we go sine of 1.9?
0.946.
And 1.9 divided by 2.
0.95.
So we're pretty close. So the solution, if we get a better approximate there, it's close to 1.9, and considering 0.01 out, okay, I would say that would be the approximate solution. Okay? And also due to symmetry, okay, we've got the sine curve going back and forwards there. Alright, and then we can take the symmetry as well because the y equals x over 2 is an odd function as well. Okay, so we're going to have symmetry on the other side. So, therefore, we know that x is 0 is a solution because it intersects the origin of both graph, and also x equals plus or minus, x is approximately equal to plus or minus 1.9. Okay, because in this course we're not going to be able to develop the skills to be able to give an accurate solution. Oh. Well, I did extra the question on there. The question really said, find graphically the number of solutions for the equation.
No,
But it's good because that was going to be the next question anyway. That's right. So that's how you find your approximate solution. So how many solutions are there? 3. Okay, so on the intersection of your graphs. Alright, so if the question asks you to find the approximate solution, that's what you need to do. Okay? So there are 3 solutions. Okay, obviously if they're asking you how many, you don't need to justify with the math this bit here. Okay, but you do need to be making some reasonable assumptions and accuracy to be able to tell me that there are 3 solutions. Okay, B. From the graph of 2 cos of x equals x, find the approximate solution. Okay, so that's what we have to do. Alright, so we've got 2b, 2 cos of x equals x. So what you need to do is set y equals for both sides to the equal sign and graph those individual graphs accurately, and then we will need to determine the approximate solution by your graph. Okay, so no domains specified, so we need to make sure make sure it's accurate as you can make it. Okay, so I'm drawing my cos curve there. So the amplitude 2, so the maximum and minimum are 2 and negative 2. Okay, so pi on 2 and pi. So pi on 2 was approximately 1.57, and I'm going to use that for my graph information because I know the point 2 lies on the graph of y equals x. Because this is 1.57, the 2 is going to be on this side somewhere of your curve. Okay, because I know this intersection at here is 1.57, and I know the point 2 is going to be on the line y equals x, so I know that the point is going to be this side of the intersection point here, but pi is 3.14, so I know it's going to be between pi on 2 and pi. This is, pi on 2. This is pi, 3.14, and this is 2. Okay, so the point 2 is going to be somewhere this side of that curve. This is 3.14, sorry, and then the distance 2 and negative 2, negative 2 and negative 2 is also on that straight line. So once I've considered that, I can then confidently graph and say that there is only one solution. Okay, by considering where your points are and changing your radians to a couple of decimal places so that we can accurately get it. So, looking at that now, what is the approximate solution for x?
pi on 2.5.
Good try. So I know the solution is going to be somewhere between 0 and 1.57, probably closer to 1.57 though. Alright. So I would try when x is, let's say, 1.4, which might be pi over 2.5. So y1 and y2. Okay, so what is 2 times cos of 1.4?
2.8.
Pardon?
Minus cos of
0.3399.
0.40 and 1.4. Really? Isn't 2 times cos of 1.4?
that can't be right.
It doesn't look right. Yeah. Yeah, might be.
39.
I would have.
0.39.
340.
Yeah, but the x value is the same as the y value, but that's the big difference between them.
One was 0.33.
Well, look, they're not that close.
That's what I'm saying. Yeah.
No, I mean, but on the graph.
Well, 1.4 is slightly less than that, isn't it? That's what I'm thinking is somewhere in this domain. Okay. X is 1. So we know y2 is 1. What is 2 times cos 1?
When it's 1, it's close.
Pardon?
When it's 1, it's close.
What is it?
1.08.
1.08. Right, so we're 0.08 out of it. Right, so that could be an approximate solution. Okay. So therefore, x is approximately equal to 1. Okay, so even though you 0.4 off the second get, alright, it made it much closer in the long run. Right, so you understand the approach, alright, and how you need to be fairly accurate to be able to do your answers and come up with a reasonably accurate estimation. Alright, last one. What are the approximate solution of tan of x is equal to 2 in the domain 0, which is less than or equal to x, which is less than or equal to 2 pi. Okay, so the first two didn't have a domain. This one I need one because this is the y equals 2, which is a horizontal line. Okay, so unless I have a domain, I'm going to be considering an infinite number of solutions. Right, so what we need to do, y equals 10x in that domain and y equals 2 also in that domain. So I don't need to consider the negative x side. Right, so every pi on 2 there is an asymptote because tan of pi on 2 is undefined. Right, so which quadrant is tan positive?
Third and first.
First and third, that means, hang on, no. Oh yeah, sorry, yep, first and third. Totally something off. First and third, that means in the second and fourth, what I was getting at is negative. So in the first quadrant, between 0 and pi on 2, tan is positive. And then the second, between pi on 2 and pi, it's negative. So you're doing a cubic sort of curve, looking curve, through that section there. And then the fourth quadrant, we're at 2 pi. Right, so I'm going to specify domain. Right, and then there's y equals 2, which is that horizontal line that crosses the y-axis at 2. Right, so from your graph, how many solutions? Alright, so we need to estimate these two x values using what we've got already. So pi on 2 is 1.57, pi 3.14, 6.28, and I've forgotten what 3 pi on 2 was. What'd you write?
It was 4.71.
Oh, sorry. Alright, so I know that's a solution close to 1.57, and I know this is a solution close to 4.71. Okay, so with a suitable approximation, so I'm going to try x is let's try 1.3. Okay, so is tan of 1.3 close to 2? 3.60. Okay, so that's well and truly out. Right, because we need it to equal 2 because y equals 2. So let's try x equals 1. Tan of 1 radian.
1.55.
Okay, so we can probably consider our solution somewhere between these two because we're on either side of 2 here. Okay, x is 1.1. Tan of 1.1 radians is 1.96, so 0.04 out. Alright, that's a pretty good approximation there. Okay, so we know that x is approximately equal to 1.1. Question should probably specify how many decimal places to approximate to, but just for the purposes of what we're doing today, that will do. Right, so that's that one. So that's approximately 1.1. We need to now do this one here. So we're somewhere near 4.71. Alright, so I'm going to go x is 4.5. What is tan of 4.5?
4.63.
Okay, so we need it close to 2. Alright, so x is, let's do 4.3. Tan of 4.3.
2.28.
2.28. I probably could get a bit closer.
Tan 4.25 is 2006.
Is what, sorry?
2.006.
2.006. So we're pretty close there, aren't we? 0.01 of that is a very good estimation. Okay, so x is also approximately equal to 4.25. So they might say approximate to the nearest whole number or to 1 decimal place or 2 decimal places. Okay. Obviously the more decimal places you go, the better your approximation will be. That's it.